Okay, now this is our second lesson of the volume chapter. We're going to discuss questions of intermediate level and advanced level. Question number 6. Again, start by understanding the question. Understanding the question is the most important part. The rest of the things remain the same. We know the formulas and there's nothing more to it, right? So just understanding the question is the most important thing right now. Okay. It says a rectangular block of metal is 0.24 meters long. So this is the length given to us. The length is given to us. And then we have 0.19 meters wide. The breadth is given to us, and 0.15 meters high. So the height is given to us. Length, breadth, and height. All the dimensions that we need are given to us to find the volume. If the metal block is melted to form a cube, okay, that means a single cube, not cubes. Find the length of each side of the cube. Okay, very simple. First of all, again, I want to revise the concept with you that take a look at this. I have some water in this beaker, right? I'm going to take this and pour it in a bowl. The water remains the same. I didn't add any more water to it, right? The beaker was completely filled, but the bowl isn't even half filled, right? Volume of water remains the same. It was what it was in the beaker as well. I didn't change any volume, but the water now looks a bit different. It had more height in the beaker. It has less height in the bowl, and it has more length in the bowl, right? So that's basically what's happening here as well. The total volume is going to remain the same of the metal, right? So the rectangular block of metal, whatever we get, the total volume is going to remain the same, even if we change the shape from a cuboid. Rectangular block basically means a cuboid, right? So right now it's a cuboid, and we're going to change it from a cuboid to cube in such a way that the total volume is going to remain the same. So our first step is going to be finding out what the volume is, and then we're going to find out which number multiplied by itself 3 times will give us the total volume, basically. So first of all, the cuboid, basically the rectangular block, right? Rectangular block of metal, which is a cuboid. Its length is given, which is 0.24 meters, 0.19 meters, and height is 0.15 meters. Again, this is all given to us in meters, but I am going to convert these meters into centimeter. Why? Because this is decimals, right? And decimals are harder to deal with. When I convert 0.24 meters into centimeters, I will get 24 centimeters and 19 centimeter and 15 centimeter. I converted the dimensions that were given to me in centimeters, and now I have whole numbers that are easier to deal with, much more better for me for calculations. So you can solve this question just by multiplying the dimensions that are given to you, and you will get this as your answer, which is then 0.00684 cubic meter. This is harder to deal with. That's why I'm going to take this one, which is in cubic centimeters. Okay, the unit is different. That's why volume is same. This volume is exactly the same as this volume, but the unit is different. For example, if I'm measuring the same length using a meter and a centimeter, both are going to be different. In meters, this length is going to be very small, and in centimeters, this is going to be about 6 or 8 centimeters, right? So units are different. That's why the numbers are looking different. This is easier to deal with, so I'm going to take this volume. This is the total volume of the cube or cuboid. I said cube or cuboid because both of them will have the same volume. The cuboid that was given to me of the metal and the cube that I'm going to make by melting the cuboid that was given to me, right? The total volume will remain the same, but the dimensions are going to change. Okay, now volume for a cube is length multiplied by length multiplied by length. Basically the same number multiplied by itself 3 times, right, is going to give me the volume. The total volume is given to me, which is this one. So volume is going to be equal to length multiplied by length multiplied by length. How am I supposed to solve this question? How am I going to find what the length is? There is a different method, a proper method for finding out what the length is, but I didn't do that because that was of a little higher level and it's going to confuse you guys. It's not of your level right now. So for now, just drop that. How are we going to solve this question? Just by starting with guesses. First of all, 10 multiplied by 10 multiplied by 10. Imagine if the length was 10 centimeters, then the volume would have been 1000. Okay, let's say L is 10 centimeters. Then breadth is also 10, height is also 10. So 10 multiplied by 10 multiplied by 10 is 1000. 1000 centimeter cube. 1000 centimeter cube is so much less than what is required, right? So 10 is not our answer. We're going to multiply 20 then. 20 multiplied by 20 multiplied by 20 is going to be 8,000. 8,000 is more closer to 6,000. So our answer is going to be in between 10 and 20 in such a way that it's going to be a little bit more than 15, right? So I'm going to try 18. 18 multiplied by 18 multiplied by 18 is going to be, because I need to make sure that I'm multiplying the same number, right? I'm going to keep guessing until I get the answer that is the most closest to what is required, right? This is required. 18 multiplied by 18 multiplied by 18 is going to give me 5,832. 5,832 is a bit closer to 6,840, but it's not enough. So we're going to keep on trying. Then after 18, since this is less, since the answer that we got is less, we're going to increase the number a bit. So instead of multiplying 18, now we're going to multiply 19. 19 multiplied by 19 multiplied by 19. The answer I get is 6,859. 6,859. This is the most closest I have gotten to the required total volume, right? The total volume was 6,840 and the answer I got here is 6,859. That's enough. We don't need to calculate anymore. This number is the closest. 20 is not the closest. 18 is not the closest. 19 is the closest one. So we're going to take 19 as our length, right? L multiplied by L multiplied by L, and this is the volume. So length is going to be approximately 19. The actual length is going to be something different, yeah. But the method that is required for us to find the exact length, that is not of your level right now. And I don't want to mention it, otherwise it will get confusing. So length is going to be approximately 19. That's enough. That's your answer. You don't have to worry about anything. What does this sign mean? This sign means approximately. Approximately means not exactly equal to 19. The length isn't exactly 19, but it's approximately 19. It's almost 19. So that's fine. That's enough. The actual length is actually going to be something like 18.98, right? The actual length is 18.98, but that doesn't matter. This is enough. So what you're going to do in a question like this, if the volume of a cube is given and they're asking you to find the length, you need to find out which number multiplied by itself 3 times, okay, is going to give you the number closest to the volume. For example, sometimes it will be exactly the same answer as well. For example, I started with the, we're going to do a similar question sooner or later in the next few questions. Question number, wait a second, which question was it? Yeah, question number 13 is similar. So when we're doing that, I'm going to explain this thing again. But for now, that's the basic concept. I multiplied 10, taking the L, assuming that the length is 10. The answer was really far from the required answer, right? Then I tried 20, it was still far. I tried 18, I tried 19. The 19 was the closest, that's why I took 19 as my length. That's going to be your approximate answer. That's how you solve question number 6. Now we're going to go towards question number 7. Okay, question number 7, again, starting with understanding the question. An open rectangular tank that is 4 meters long, the length is given, okay, 2 meters wide, again, breadth is given, and 4.8 meters high, height is given. All 3 dimensions are given to us. Is initially 3/4 filled with water. Again, we have a, basically I have this. What do they mean by an open rectangular tank? They mean exactly this thing that I had in the start, right? This is a rectangular tank which is open, right? So this is an open rectangular tank. And it is 3/4 filled with water, not completely filled with water. The water isn't on the literal. Okay, I made a mess. I knew I was going to spill the water eventually. Anyways, look at this bowl, right? It's not completely filled with water. It's not even half filled with water. So the same, we have the rectangular tank, which is not completely filled with water. It's 3/4 filled with water. What does that mean? That means if I if I take the total volume of the rectangular tank and cut it into 4 parts, 3 of them are filled, 1 of them is empty, right? So I'm going to first find the total volume of the rectangular tank, then I'm going to multiply it with 3/4. Why 3/4? Because that's what 3/4 means. 3/4 means 3/4 basically. 3/4 is filled with water. Find the depth of the, what does depth here means? Depth basically means height. Find the height of the water in the tank after 4,000 liters of water is added. Step by steps. Okay, first of all, let's find the total volume. Okay, then we're going to understand what else the question says. So we're going to start with the cuboid. First of all, it's a rectangular tank, right? So rectangular tank means it's a cuboid, and cuboid length is given, breadth is given, height is also given to us. We need to find the total volume. What do? Multiply them together, or multiply them all together. We will get the total volume. Since all the dimensions are in meters, that's why the total volume is also going to be in cubic meters, right? Then the question says it is 3/4, means 3/4 filled with water. Means that the volume of water is going to be 3/4 of the total volume, right? So 3/4 multiplied with the total volume. Once I get the total volume, I'm going to multiply 3/4 with it, and I'm going to get 28.8 cubic meters. That's the total volume of water right now. After I add 4,000 liters in it, it's going to be different. But 4,000 liters is a different unit. Liters is a different unit from cubic meter. So I'm going to first convert the liters into cubic meters. So when I convert again, okay, now we'll be converting the 4,000 liters into cubic meters. How do we convert liters into cubic meters? Divided by 1000. So 4000 divided by 1000 will give me 4 cubic meters of water I am going to add in the already given volume of water. So 28.8 plus 4 is going to give me 32.8 cubic meters of water. This is the new volume of water, right? This is what the question tells me. Now, since the volume increased, for example, again, I'm playing with water here. Let's say this was the initial volume of water. It's only this much filled, right? Now I added 40. Okay, let's analyze this first. This is the given volume of water in the question in the start, right? This volume of water has a specific length, it has a specific height, and it has a specific breadth. This thing is circular, cylindrical shape, so I can't really show you the length and breadth and height properly. I need a rectangular thing for that, but I don't have it, so you're just gonna compromise with this one, right? Anyways, the point is, length and breadth, they won't change. Let's imagine that this is length and it goes like breadth there, right? So length and breadth won't change, but the height of water can change. How? If I add more water, look, I added more water, now the height increased. The water came upwards, right? So the more water I add, the more it will go upward. The water that I take away from this tank, the water will go downwards. So the height can change, but length and breadth won't change, okay? Similarly goes for every other shape as well. If I take this tank and I fill it with water, in the start it will be less. The length and the breadth will remain the same. The length and the breadth will remain the same, but the height can change depending upon the more water I add or the water that I take out from the tank, right? So we added water here, right? The volume of water that was already there, it had a specific height. When I added more water in it, the height increased because I got more water rising upward, right? So the new volume made a new height. New volume of water gave us a new height. The length and breadth is going to remain the same. In the question, it was given that the length is 4 meters, so it's going to remain the same, 4. The breadth is also going to remain the same, 2. But we don't know the new height. After adding more water, the height increased, right? The water rose upward. So what is going to be our new height? We don't know that, but we know the new volume. The new volume after adding the water was 32.8 cubic meters. I'm going to take that volume and I'm going to take the length and breadth that was already given in the question, and I'm going to find the new height, which is going to be the depth, right? So just putting the values in the formula, I can solve it further to find the value of h. Before, the value of h was different, right? We don't know what the value of h was for water. This value that was given to us, this is the whole tank itself, right? Here, the height basically that is given here is the whole cylinder, whole tank itself, the height of the tank itself, which is much more than water. Water is here, the tank is here, right? So it's much more than water as well. So that is what's given in the question. The initial height that the water had, that's not given in the question, right? And that's not even required. It doesn't even matter. The thing is, once you find the height from the new volume of water, that's the depth of water after adding 4,000 liters in the already given volume of water, right? Depth basically means height as well. This was question number 7. But remember this, okay? As water in the tank, as it is the water in the tank, it has its height can change, okay? With water rising upwards, if I increase water, if I decrease water, the height will change. But the length and breadth of the container, it remains the same, okay? You've dealt with similar questions in grade 5 as well, but I thought it would be good to explain this once more. Okay, now we're going to deal with question number, let me just remove this water. Yeah, now we're going to deal with question number 8. Question number 8, the diagram is given to us. It says the internal dimensions of an open. Again, in these questions, you have to make sure you understand the process, the diagram, the volume, the thing that is happening, okay? Other than that, the formulas don't change. They're the same formulas that we've used over and over again in this chapter. Here, you need to make sure that you understand this diagram for you to be able to solve this question. The internal dimensions of an open wooden box are given, right? Internal dimensions. What does that mean? I'm going to explain. The wood has a thickness of 0.2 meters. Find the volume of the wood used. Okay, let me just show you one more thing here. Take a look at this. This is let's imagine this is the wooden box that we're talking about. Imagine this is the wooden box, and ignore the fact that it's very dirty. I just had to pull it out from the storage. Anyways, this is the wooden box. It has, first of all, it has a length, okay? It has a length, it has a breadth, or you can call this length or this height and this breadth, okay? But the fact is these are different, right? So we have a height, we have length, and we have breadth. Let's just say that. This will be our height, this will be our length, height, and breadth. Okay, other than that, I have this thing, this thickness here, right? Question says that, question doesn't tell us this, Okay, question doesn't tell us the height of this box. It doesn't tell us the length of this box or the breadth. It tells us the internal one. Okay, just take a look at it. Take a look at it like this, right? We have a bigger rectangle on the outside, right? We have a bigger rectangle on the is that a rectangle or a square? It looks like a rectangle to me. Anyways, we have a bigger rectangle on the outside, right? And then we have a smaller one on the inside. And in between those big and small rectangles, we have this thickness, this foam, right? We also have one open end. The top is open. The bottom has a foam in it, right? And the foam also, in the bottom foam also has a thickness, a specific thickness. So in between this finger and this finger right here, there's foam. There's foam of how much length? Almost this much length, right? Almost this much foam is there, right? So understand this figure properly, okay? We have one. Let's imagine this doesn't exist. Let me close this, right? So with a piece of paper, let's say I closed it. See, I closed it, right? Now it's a complete box, like it was in the start. Now this box has how many dimensions? 3 dimensions. It has a length, or you can say this is going to be our length, this is going to be the breadth, and this will be our height, right? Height. So imagine this is a complete box. Inside of it is hollow, right? As we know, the inside is hollow. How can I find the volume of only the foam? How can I find the volume of only this foam area, not what's inside, or not the whole thing itself? For example, if I just multiply, for example, I have this box, right? Let's look at it like this. It's a complete box. Forget about the fact that it has open or hollows in the inside, right? Forget about that. For now, just think of it as a box. I'm going to multiply the length with breadth and height. I will get the volume of this entire box. I will get the volume of this entire box. But that's not what I want. I want the volume of only the real material inside it, not the hollow shape. This hollow gap inside it is a volume. Okay, you tell me, is this the space inside a real object? Yeah, this is a space inside the real object. It's an empty space, but it is a space inside real object, right? So it will have a volume. This will have a volume too. But we don't want that. What do we want? We want only this volume. This is a real object, and the volume inside this thickness, right? The volume here, the volume all inside it, that's what I want to find. The volume inside this styrofoam itself, that's what I want to find. How am I going to find that? Basically, we've done something very similar to that. Let me revise a few things here that we've done in chapter number 8. And the question also came in our previous assessment exam as well. Okay, let's say I have this. Let me use a better pen. Yeah. What is this? It's a rectangle, right? A rectangle has a small rectangle inside it. This bigger rectangle, right? This is the path. We've done a similar question in chapter number 8. This is the path. This is the bigger rectangle. This is the smaller rectangle, correct? How can I find the area? Look, if I multiply this length with this breadth, what will I get? I will get the whole area. I will get the area of the entire large rectangle, the bigger rectangle. I'm going to get the area of the bigger rectangle. That's not what I want. I want the area of only this specific frame that I have, right? So what am I going to do? I'm going to find the area of this entire big rectangle, and then I'm going to find the area of this small rectangle, and then I'm going to subtract the small rectangle from the big rectangle to find the frame. Let me show you it in a more realistic way. Take a look at this shape. It's a rectangle, right? It's a rectangle. Inside this rectangle, I have a smaller rectangle, right? I have this smaller rectangle. So if I multiply this length with this breadth, what am I going to find? I'm going to find a complete space inside it. Okay, everything. This thing as well, this thing as well, this, all the area inside this, I will find it by multiplying this length with this breadth. Okay. I have this smaller rectangle. I can find its area by multiplying the smaller length with this smaller breadth, right? This smaller length with this smaller breadth. I can find everything, this, all the space that is inside, all the space that is inside this smaller rectangle. Okay, my purpose is to find the area of only this frame, not including the space inside, not this part, okay? I don't want that. I want just this frame. I want the area of this frame. So what am I going to do? I'm going to multiply this bigger length with a bigger breadth, right? I'm going to find the area of the external rectangle, and then I'm going to remove the internal rectangle from it, which is the smaller length with the smaller breadth. I'm going to multiply them to find this area and the bigger area, and then smaller area subtracted from the bigger area, I will get my I will get what? Only the frame. Basically, large area, and then I'm going to find the smaller area, subtract it, throw it away, and what will I be left with? I will be left with the area of the frame. Okay? Very similar thing we're going to do in this chapter here with this box. I'm going to find what the complete box is. Okay? Where is the page? Where did the page go? Yeah. I'm going to find the entire volume of this box. Entire volume, including this space, empty space inside it, including the empty space. Okay? I'm going to find that first, and then I'm going to subtract what? The empty space from it. And what will I be left with? I will be left with the area that is covered by this foam, all of this foam. Okay, that will be the actual volume of only the foam itself, right? I can do one more thing. I can cut this whole box into smaller pieces, okay, and stack them all together. I will be left with a complete cubic shape or like a cuboidal shape of this styrofoam. And then when I find the volume of that, it will be exactly the same as what I'm going to find right now. Okay, basically, again, going back to the question. Question says, take a look at the diagram. Take a look at the diagram. It has given you the inner, okay? It has given you the inner length. That means this 3.2, what is this 3.2 meters? This 3.2 meters is basically from this inner end to this inner end, right? It's the smaller one. This is 3.2, right? Okay, 3.2, and then we have 2.5 here. Is it 2.5? Yeah, since the thickness is 0.2. Okay, it's not 2.5, it's 0.2. Since the thickness is what? In the question it says the thickness one, it is 0.2 meters. Thickness is 0.2 meters. That means this thickness, that's 0.2. What thickness? This thickness. This is 0.2. Okay, this is also what? 0.2. This is also what? 0.2. All of them have a thickness of 0.2. 0.2 here, 0.2 here. All of them has a thickness of 0.2. So if this is 13 point, this is what? Sorry, this is 3.2. Yeah, if this is 3.2, right? This length is 3.2 given in the question. 3.2. Then we have 0.2 here and 0.2 here. 3.2 plus 0.2 plus 0.2 will give me what? 3.2 plus 0.2 plus 0.2 is going to give me 3.6, right? 3.2 plus 3.2 plus 0.2 plus 0.2 is going to give me 3.6, right? 3.6 will be what? 3.6 basically will be the larger length from this corner, from the outer corner to the other outer corner. This will be 3.6, and the inner one is what? 3.2. Basically, we're going to repeat this process for all of them, right? All the sides. This side was what? This side was 2.2. This side was 2.2. 2.2 plus 0.2 here and plus 0.2 will give me the outer length. And the height. Now height is 1.5 plus 0.2. Why? Why is 1.5 plus 0.2 not plus 0.2, right? Like in the other ones, in the length and in the breadth, I added 0.2 two times. From here and here as well, from here and here as well. From here and here and from here and here as well, right? But why didn't I add 0.2 two times with the height? You can take a look at this. Is there any top here? No, there is no top. There's only the bottom that is covered, and bottom has a thickness. I told you it's almost this much thickness. At the bottom we have this much styrofoam that goes and covers this part, right? It's not open. This one is open, so it doesn't have any thickness here. It has thickness here. So this length is given to you. Let me just mark it. Yeah, this length is given to you. In the book it says this much is what? It's 1.5 meters. This is 1.5 meters, and this small is then what? Is the same thickness that is given in the question, which is 0.2 meters. So 0.2 meters plus 1.5 is going to be 1.7 meters. So the total height on the outside is going to be 1.7 meters. That was a basic concept of it. Okay, now going back to the writing. We had the volume. This question took a long time because it had a lot of concept. Volume of inner cuboid, right? First of all, the inner dimensions. Internal dimensions basically means the internal empty space inside this wooden box, right? So inner dimensions, we're going to first find the volume of that, and then we're going to find the volume of the outer cuboid, the bigger cube, right? Including the inner space right there. And then we're going to subtract the volume of the inner cuboid from the outer cuboid, right? So the volume of the inner cuboid is going to be length multiplied by breadth multiplied by height. The length is given to us, which is 2.5. All the dimensions of the internal is pretty much written in the question. So you're going to multiply 3.2 with 2.2 by 1.5. You're going to multiply them. You're going to get 10.56 cubic meter. That's going to be your inner cuboid, right? Basically, that's the volume of this empty space inside it, okay? That's the volume of only the empty space inside this open tank, wooden box, you can say. Then we have volume of the outer cuboid, but the dimensions of the outer cuboid are not given in the question, right? It's given in the diagram. The length is 3.2, which was the inner one, right? 3.2 plus 0.2 plus 0.2, which is going to be 3.6. Here we have inner one, which is 3.2 plus 0.2 from here and plus 0.2 from here. This thickness plus this thickness will give us 3.6 meters. Okay, then breadth again 2.2 plus 0.2 and plus 0.2. Let's say this time this side was what? Length. This side is now what? It's our breadth. So this was the internal dimension that was given from here to this point, which was 2.2. Now 0.2 plus here and 0.2 plus here. So 2.2 plus 0.2 plus 0.2 will give you 2.6 meters. Height is going to be then, since we don't have a top here, we don't have a top, so we don't have a thickness on the top as well. So the height is going to be only added from the bottom. I showed it here. Yeah. Since we don't have a top here, so this is going to be the internal height plus this is the thickness, 0.2. Okay, so 1.5 plus 0.2, which is going to be 1.7 meters. Multiply them all together, you will get the volume of the outer cuboid, which is 15.912 cubic meters. Now the volume of wood used is going to be the volume of outer minus volume of inner, right? You just subtract it and you'll get the volume of the wood used. This was a bit more conceptual question, but it again is pretty important for you to understand what this is, right? This is one of the most basic and interesting questions in volume. Then we have again a very similar question. Question number 9 is, we don't have any written thing given to us, but it's pretty much exactly the same as question number 8. First we're going to find the volume of this outer cuboid, and then we're going to find the inner cuboid, and then we're going to subtract the inner cuboid from the outer cuboid. The length is given to us for the outer cuboid, which is 45. The breadth is also given to us for the outer, which is 15, and the height is also given to us, which is 10. So 45 plus 15 plus 45 multiplied by 15 multiplied by 10. That's going to be your outer cuboid's volume. Then the inner one has 3 and 2. That's the length. Length is 3, 2 is the height, and 45 is again the same. The height is same for both of the cuboids, inner and outer cuboid. Both of them have same heights. So we're going to multiply length, breadth, and height of the inner one. Once we get that volume, we're going to subtract it, just like this. We've done it here. Outer cuboid is length multiplied by breadth multiplied by height, 45 multiplied by 15 multiplied by 10. This is the outer cuboid. Then the inner cuboid, 45 multiplied by 3 multiplied by 2. Once you get this volume, you're just going to subtract. The volume of the hollow glass is going to be 6,750 minus 270. This was exactly the same, a very similar question to what we did in question number 8, right? Question number 9 was very similar. We just have to subtract the inner from the outer one, and we'll get the volume of the hollow glass. Okay, question number 10 then. Question number 10 is much more simpler and easier. It says an open rectangular tank, just like this one, or just like this one as well. It's an open rectangular tank. Okay. Oh, that one. Yeah. So we have an open rectangular tank of length given to us, breadth is also given, and height is also given. Okay, it contains a water of height this much. This is the height of the water inside it. We don't know what the actual height of the rectangular tank is. We just know the height of the water, but it's not really important for us to know the height of the actual tank because it's totally irrelevant. We don't need it for anything. We need the volume of the water, right? Volume of the water is basically the length multiplied by breadth multiplied by height of the water. So you have the given data, you just have to multiply them for you to get the volume of water. But the thing is, length is given to you in meters, height is given to you in meters, and breadth is also given to you in meters. So the volume that you're going to find is going to be in cubic meters, and you are the question asks you to give the answer in liters. So once you get the answer for multiplying them, you're going to convert that into liters. Okay, so part 1, length is given, breadth is given, height is given. You're just going to multiply them by using the simple formula that we have. The answer that you're going to get is in cubic meters, and you're going to convert those cubic meters into liters. The way we convert cubic meters into liters is by multiplying 1000 with it. So just multiply 1000 with the answer that you got. You're going to get 4.8 liters. That's going to be your answer. That's it. Then they're asking you to find the surface area of tank that is in contact with the water. Now this is the conceptual part of this question, right? Now I want you to understand. It's an open tank, right? An open tank has how many faces, right? Let me show you this again. Wait a second, let's zoom out. This is the open tank, right? No face on the top. One face here, 2, 3, 4, and 5. We have a total of 5 faces. So if I put water in here, water is going to touch this place, this place, this place, this place, and this place. On 5 different places, it's going to touch the tank, right? Not on the top. There is no top. So it's only going to be in contact with the tank in 5 faces. So do we know the total? But the formula that we have, let me show you once again. This formula, which is the formula of total surface area. Total surface area is made from 1, 2, 3, 4, 5, 6 faces. We're talking about a cuboid. It's a cuboid, right? It's a rectangular tank. So we're going to discuss this formula. We have 1, 2, 3, 4, 5, 6 faces. But our tank, in this question, we only have 5 faces. What are we going to do? We're going to use this formula exactly as it is. And then after the calculation is done, we're going to subtract one face area. Okay, area of one face is length multiplied by breadth. So we're going to look at the top. Is there any height in the top? No, it's only length multiplied by breadth. So we're going to multiply length and breadth and remove that face away. Okay, so we're going to use the formula just like it is given, just like we have always used. The length and breadth and height is already known to us in this question. So we're just going to apply this formula. Once we know the total surface area, then we're going to subtract length multiplied by breadth from it. Okay, take a look at this. I just did what I had to, right? Like just in the formula. Cuboidal shape, that's why I'm going to use this formula. Total surface area is equal to length multiplied by length, 2 multiplied by length multiplied by breadth, length multiplied by height, and breadth multiplied by height. Just put the values. Once you get the total surface area, then the surface that is in contact with water, you're going to subtract length multiplied by breadth from that answer. Okay, this is the total surface area that I got. I'm going to subtract the length multiplied by breadth from it. This is what? This is area of the top face, which is missing, right? Area of the top face, which is missing. So I'm going to subtract that from it, from the formula. And I will get my answer basically. So 0.172 minus 0.03. I will get my answer, which is the surface that is in contact with water. Again, a cuboidal shape has 6 faces, but in this open tank, we only have 5 faces that are in contact. So what are we going to do? We're going to remove one of the faces. And what is the area of one face? It's length multiplied by breadth. So we're going to remove length multiplied by breadth. Okay, that's the only conceptual part of this question. It's pretty much, other than that, it's pretty easy. Question number 11, basically a fish tank measuring this by this contains, this is what? This is basically length multiplied by breadth. Length and breadth is given to you. It contains a water of height 35 centimeter. Again, the height is given to you. Length is given, breadth is given, height is given. What do we need to do? We need to find the volume of water, and then we need to give our answer in liters. We have the dimensions in centimeters, so centimeter multiplied by centimeter multiplied by centimeter. The answer that we're going to get from the volume here is going to be in cubic centimeters. So we need to convert that into liters. So first, let's find the answer of part 1, question number 11. Length multiplied by breadth multiplied by height. Just put that in the formula. Proceed. You will get the volume. You will get your answer in cubic centimeters. Then we need to convert that cubic centimeters into liters. How do we convert cubic centimeters into liters? We divide it by 1000. So so the answer that you got, you're gonna divide it by 1000, and you'll get 112 liters. That's the total volume of water. Okay, that's the total volume of water. Then what are you gonna do? You're going to, the second part of the question basically asks us to find the surface area of the tank that is in contact with the water. Again, oh sorry, that was the question number 10. Okay, question number 11, part 2. The surface area of the tank that is in contact with water, exactly the same as question number 10, but we need to give our answer in meter square, basically square meter, right? So we need to give our answer in square meters. Let's just first find the surface area exactly the same way as we did before. We have only one formula of surface, total surface area for a cuboid, which is this one, right? So we're going to use that formula. We know the length, breadth, and height. Just put the values in the formula. You will get the total surface area. But the total surface area also includes the 6th face, which is missing in a fishing tank. Fishing tank is also open from the top. That's why the water is not in contact from the top. So we're going to remove the top face. Top face is what? Length multiplied by breadth. So we're going to remove that. Once you get the total surface area, which is this. You're going to find the surface that is in contact with water, and that's going to be the total surface area minus length multiplied by breadth. What is length multiplied by breadth? You already know that is 3200, right? So 14,800 minus 3,200, this is the total surface area that is in contact with water. The answer that we got and every calculation that we've done up until now was in cubic centimeter. That's because what was given in the question. The dimensions given to me was in centimeters, right? So that's why the answer that I got was also in square centimeter. But we're going to convert that square centimeters into meters. How do you convert square centimeter into meters, square meters? You're going to divide by 1,000. Remember this, okay? This is from chapter number 8. How to convert square centimeters into square meters? You divide it by 1,000. So the answer that we got, we're going to divide it by 1,000. We're going to get 1.16 square meters. That's going to be the surface in contact with water. Question number 10 and 11 was pretty much the same, but just in question number 11 we had to change the units. Okay, question number 12. Now here we have, let's see, question number 12, we have a metal cube that has a volume of 64 centimeter, cubic centimeter, right? So it's a cube with a volume of 64 cubic centimeter. It has to be painted in all its sides, in all its faces, right? Find the total area of the face that will be coated with paint. I mean, it's pretty obvious that, let's just say this is the metal cube that we're talking about, and we need to paint it on all sides, this side as well, this side as well, this side as well, this side, all the sides. Basically, what is this side? It's a square, right? It has an area. They're asking us the total area, and we know what the total area is. Total area is, total surface area of a cube is, we've done this here as well, you can say 6 multiplied by L square. If you remember the formula, that's the total surface area of the cube. They're asking us to find the total surface area of the cube. But to know the total surface area of the cube, I need to know the length. Do I know the length? Is the length given here? No, the length is not given here. So first we need to find the length, and then we're going to put it in the formula of 6L square, right? So first of all, the volume is given. This question is pretty much very similar to the question that we discussed before. If the volume is given, how can you find the length? You basically have to guess it. 10 multiplied by 10 multiplied by 10 is 1,000. 1,000 is so much more than 64, so our answer is going to be less than 10. So we're going to do 5 now. 5 multiplied by 5 multiplied by 5 is 125. Still more than 64, so our answer is going to be less than 5 as well. We're going to do 4 multiplied by 4 multiplied by 4, which is 64, right? Exactly the same. That means 4 is the length. Volume is equal to length multiplied by length multiplied by length, right? That's why we're guessing it this way. Once we know the length is 4, because if the volume is 64 cubic centimeters, then the length is going to be 4 centimeters, right? If, for example, it was something else, for example, if the volume was 125, we again would have had to guess. Again, starting from the most simple one, 10 multiplied by 10 multiplied by 10. If the answer is, if the volume that is given to us is more than 1,000, then I need to try a number that is higher than 10. Okay, I need to assume a number that is higher than 10. If the volume that is given to me is less than 10, then I need to try a number that is less than 10. It's basically much simpler for me to go in the 5 table. For example, first I'm going to multiply 10 multiplied by 10. If I see that the number is a lot more than 1,000, then I'm going to try multiplying 20 with 20 with 20, seeing if it's in between those numbers. For example, I multiplied 5 multiplied by 5 multiplied by 5, right? 5 multiplied by 5 multiplied by 5 will give me 125. 125 is still more than the volume that is given to me. Then obviously, then the length that I will need is going to be less than the one that I did, okay? So I'm going to go less than 5 next time. If it was, assume that it was not 4. Let's say it was, let's say the volume given to me was, let me pick a rough page here. If the volume given to me was 27 centimeter cube, if it was this, then obviously this is even less than 4 by 4, so I'm going to try 3 multiplied by 3 multiplied by 3. 3 3s are 9. 9 multiplied by 3 is 27. It's exactly the same. So I'm going to keep guessing until I get the right answer, or I get the answer that is the most closest to the volume that is given to me, right? That will be my answer then. That will be my length. Once you know the length, you just have to put it in the formula. Total surface area is equal to 6 multiplied by L square. We know the L, which is 4. So 4 square is 4 multiplied by 4, which is 16. So 16 multiplied by 6 will give you 96 square centimeters. It doesn't ask us to convert it in any units, so that's basically the total area of the faces that will be coated with paint. That was question number 12. Question number 13 is a bit, you need to change it. Okay, it's wrong. It's not wrong, but if you try to solve it with the given information in the book, then it's going to require a method that you don't know yet, and that's why I just changed the number 433.5 into 486. Okay, you're going to change the number 433.5 into 486. Okay, make sure to do that. I'm going to explain why you need to do this a bit later. First, let's solve the question that I've written now. Okay, the total surface area of a cube is given. We need to find its volume. Nothing else is given to us. Okay, total surface area is given. We don't know the length, we don't know the breadth, we don't know the height, and we don't know the volume as well. Just the total surface area is given. But another piece of information is given to me. It's a cube. A cube has length equal to breadth equal to height. That means we only need to find the length anyways. If I can find the length, I can just multiply it with itself 3 times and I can find the volume. How can I find the total? Okay, here. It's a cube, right? So the formula for total surface area of a cube is 6 length square. 6 multiplied by L square, correct? Total surface area already given in the question is 486 cubic centimeters. So 486 is going to be equal to 6 L square according to the formula, right? I just replaced the total surface area with the value that was given in the question. So we have 6 multiplied with L square. So divide 6 on both sides. 486 divided by 6 is 81 is equal to L multiplied by L, right? L multiplied by L because that's L square, right? So 81 is equal to L multiplied by L. What number multiplied by itself is going to give you 81? Obviously 9. 9 is basically 81 is a perfect square, right? So 9 multiplied by 9 is 81. So we now know that the length is what? 9. Length is equal to 9 centimeters. So what are we going to do? We're just going to put the value in the formula of volume. Volume is equal to length multiplied by length multiplied by length. Since it's a cube, so 9 multiplied by 9 multiplied by 9, and you will get the volume that is required in this question. It wasn't really that difficult, but the problem is, if this volume was what was given in the question said, before my correction, the question said 433.5. Now this 433.5, this, if I divide this by 6 and I try to find the perfect square, I won't be able to do that. I will need to use different methods which are not discussed in your course, and it's not of your level basically. So we're not going to discuss those methods right now. That's why if I was to solve this question through those methods, you will get confused. We're right now, our focus is to learn volumes, okay, and how to deal with volumes. That's our main focus, and the total surface area, right? Right now we don't need to overdo ourselves or try to do things that we haven't done before. Just focus on volume and total surface area for now. So do this correction and then solve this question, okay?